Okay, so I'm Zane Lackey. I built and led the security team at ISSA. I was previously the director of security engineering there. Just left about a month ago to co-found Signal Sciences, but this talk is really around kind of lessons learned and practical approaches to what's kind of traditionally been called network security. So kind of what's been interesting, what were the lessons learned there, especially in kind of DevOps sort of environments and things like that. And my background before that was much more in kind of offensive work, so in offensive research, pen testing, that sort of stuff. Shout outs and thank yous. Oh, speaking of shout outs, don't even worry about raising your hand for questions. Like, this is way better if we have this be a conversation, and even if we get a little off track into something that's interesting, let's do it. Just shout stuff out, raise your hand if you want to, but let's just make lots of questions throughout. Shout out to the other teams that we really did a lot of collaboration with, and the point of this actually is a specific thank you to them and everything, but really around the fact that reach out to a lot of your peer organizations. That's one of the most compelling things I think that was really interesting to me when I first went into defense was how much people are really open to sharing their approaches and things like that, and not just inside your own kind of industry, but really across industries. So if you're not talking with peer organizations, if you're not talking with other organizations, I would strongly recommend it. The funny thing is even really, in a lot of cases, even competitors talk at the security team level of like, hey, did you guys see an attack like this? And like, yeah, totally. We saw this one, they were going after that. Sharing data on approaches and on incidents and things like that is incredibly valuable. I cannot stress it enough. So what is Etsy? Etsy is an e-commerce. Does anyone know what Etsy is? Yeah, okay. Great, so all your hand-knit goods, as long as they're free range and cruelty-free, are all on Etsy. And one of the funny things as we were starting to build the team and everything like that was after a couple beers, people would always ask us like, okay, so Etsy, like why do you even have the security team, right? It's like a knitting website. And the answer that you can always give to that is we face a lot of the same threats that everyone does, right? And any acronyms you get to use in that are always fun. Okay, so don't worry, the jokes get even worse from there all throughout, so it's going to be a long hour. So this talk is about how do we shift our approach around network security? How do we shift from what I kind of say is uncontextualized approaches to network defense to how do we really go around kind of patterns of real-world attack? And that's really the theme of this talk, is how do we shift from the way that we've thought about network security to the way in which attackers actually attack systems? Because it turns out it's been a pretty divergent set of things there. We've defended one way, attackers have attacked another way, and it's no surprise that attackers win. So what do I mean when I say uncontextualized? I'd say really three things. We've focused on this concept of a perimeter, even though that as a concept is loose at best, we'll say. We've deployed a lot of products that don't address how people actually compromise systems. And then we've treated a lot of vulnerability enumeration or even compliance as pen testing. So this has always been a lot of problems of you do your once a year pen test for PCI and you assume that you're getting real data out of that. And so I'm going to talk about kind of breaking these down from the defensive side of how we kind of rethink these problems. So like I said, these don't address how people are actually compromising systems today. And so it's great to stand up here and say like, oh, these things don't work and these things don't work and everything like that, but what should we actually be doing? First, we should be focusing on how do we raise cost to attackers? How do we start to impose actual cost of attack? How do we increase the odds that we detect a compromise? And hopefully we increase the odds both that we detect it and the odds that we detect it sooner and sooner in the attack chain. And then finally, how do we iterate based all of those approaches? How do we iterate it based on real data in kind of a continuous loop to always be adjusting our defenses? So this is really kind of the agenda for this talk, which is how do we impose cost? How do we detect compromise? And then how do we start to iterate and change our whole approach around that? So increasing detection. This is really the theme of the talk. Building your defenses from an offensive mindset, right? Rather than the kind of historical approach that we've had of, okay, I've got my security checklist for the next 5 years, right? I need to go buy a firewall and deploy that. I need to go buy IDS and deploy that. I need to go kind of deploy these certain technologies and check those off the list one by one. And the problem is, that's really not how we're all getting compromised. And where you see this a lot is in things like kind of arbitrary severity ratings around like network scans and things like that, right? A common CSO policy that you see, and it's not wrong, is that, okay, I'm going to do a scan of my network. I'm going to, the issues that it discovers are rated 1 through 5 in severity, where severity 5 is the worst. I'm going to set a policy that every severity 5 has to be fixed within a day, every severity 4 within a week, and every severity 3 within a month, and then we don't really worry about 1s and 2s. And the problem with how this breaks down is how we all actually get compromised is in a lot of times chains together of 1s and 2s, right? It's very often, we're really seeing the decline of kind of the severity, the externally facing severity 5 as being the point of compromise, right? Where we saw that was very historically where you saw edge servers with kind of no DMZ or anything like that, and they had some out-of-date software that was just externally network facing, and that would get compromised, and then they'd come to the network that way. How do we actually see compromise today? It's compromise of endpoints, right? You land on someone's laptop, and you move internally from there. So this whole kind of section breaks out into these three, which is how do we start focusing on detecting initial compromise? How do we detect persistence and command and control? And how do we detect lateral movement inside of a network? So initial compromise. I absolutely love that one. So this is meant to be kind of a baiting slide, but rootkit your endpoints in your environment before your attackers do, right? Start to instrument your environment before your attackers do it for you. So, and when I say endpoints, I mean desktops, I mean laptops, I mean what are the systems that your employees are using in your environment. And what you kind of start to look for on that is you start to look for both behaviors of behavioral changes on the system a bit, but really around like commands executed and things like that. First, you need to instrument these systems to collect that data, and then you can start to look for very interesting things that start to become kind of patterns of compromise. So I'll talk about one specifically, which is logging commands that execute on endpoints. You want to log this sort of data and collect this sort of data, and then you can start to analyze it for really interesting things. So from there, you start to build alerting off of anomalies and things like that. So what do I mean? What do I actually mean when I say anomalies? The way that you can approach this effectively in an organization is if you push out command logging to all of your endpoints, you then start to bucket your users into technical and non-technical. And from a very macro level, that kind of gives you the interesting differentiation that you need. Because from there, you can start to break it down into what's anomalous for a non-technical user, what's anomalous for a technical user, and what's just always anomalous in my environment. So again, staying with command execution. You can look at, for your non-technical bucket, it's really easy, actually. It's the easiest one. Because you can say, if there's anything that is anomalous and shows technical, or if there's anything that shows technical capability for your non-technical users, that's anomalous. That's not guaranteed to be malicious, but it is guaranteed to be anomalous. Right? So as I said, it's either an attacker or your IT team. How that starts to, to give you practical examples of this sort of stuff, instrumenting your customer support reps. Let's say you have customer support reps, you instrument their laptops to detect when commands are executing on those laptops. If your customer support rep is suddenly running netstat and ifconfig and route and telnet, that's not your customer support rep, right? That's either someone who landed on their box or that's someone doing maintenance on that system. For your technical users, it gets a lot more challenging. You can't just say like, okay, technical commands, that's anomalous, because for your technical users, that's normal. If your ops engineers are running telnet and netstat, that's just a normal day at the office. That's not anomalous. What you start to look for is really two things. You start to look for really what looks like bursts of recon on the system, and whether that's chains of commands that execute. Right? Maybe you're to stick with like these kind of arbitrary examples of commands. If your ops engineer runs netstat or telnet, like no big deal. But if they run 10 of those similar commands in a very short window, that's not them. That's somebody learning about the environment. And so you start to look for what are the chains of commands that come together that indicate recon, and then what is the velocity of those commands, right? You may have technical commands that execute all day, every day because they're technical users, but they don't happen with 15 of them in a 5-minute window. That's someone trying to learn about the environment. And then what's just always anomalous across the entire organization. And this is where you start to go look at what are the different attack patterns regardless of the organization that attackers really start to use. What are the things that you as an attacker do when you land inside a new environment As a defender, you want to go instrument for those. I jokingly mentioned uname, right? Go look at Pastebin and go look at all of the dumps of, haha, we just compromised this organization, blah, 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 here's all their info. And go look and see what commands run in there. And then see if your users actually run those on a day-to-day basis, and they don't. And so it's really interesting because you can start to look for what are the commands that attackers always use and your users never do, and light up when those start showing on your systems. We've had really interesting success with that. Okay, moving on to persistence. So I'm going to talk about two categories here. I'm going to talk about host level persistence and then organizational level persistence. So host level, really what you're looking for here is to kind of increase attacker cost. You want to look for your goal out of host level persistence detection is to make it so that people just can't use off-the-shelf stuff when they're compromising your organization. Right? You're not going to detect the most sophisticated things or even fairly sophisticated things, right? You're not going to be writing anything you're going to push out to your endpoints that's going to detect when someone has hardware rootkitted someone's laptop as they're crossing a border checkpoint. It's just not going to happen. And even sophisticated rootkits that land on there at all, like you're just not going to detect those without, a crazy 1,000-person security team looking at every event that happens on every OS inside the organization. In practice, what you're going to do is you're going to detect the basics. And this is really good because A, you detect a lot of stuff with that. And B, as your attackers keep coming back, you're making them customized for your organization. And that's a real cost for attackers, right? If they have to adjust their tooling specific to your organization, for whole sets of attackers, you've already won. Right? For certain sets of attackers, if they have to customize everything to you, but they could just reuse their tooling for everybody else, and they're interested in credit card dumps and things like that, PII, they're just going somewhere else. Right? In a lot of cases, it's purely economics. If I can compromise X, but I can't compromise Y without changing my tooling, I don't care. I just want credit card numbers at the end of the day. I'm going to go attack X. Similar to the joke about you're not outrunning the bear, right? You're just outrunning the people next to you. It applies a lot in security, actually. So I want to give a shout out to MimeFrame. I would strongly recommend Googling like MimeFrame RuxCon 2012. Facebook did a really good talk in 2012 at RuxCon, and a couple of their slides were on a OSX persistence mechanism detecting tool that we've actually since, I need to update this slide, we've actually since collaborated with Facebook, and ISSA and Facebook published a joint tool called Midas, which is a OSX instrumentation framework for detecting compromise. It's kind of a OSX HIDS, if you will, or the framework for it. So ISSA, given that is a company focused on cross-stitch and things like that, the jokes will never end on that, don't worry. What's the ISSA host IDS? Well, it's not Tripwire, it's definitely TripYarn. So we wrote this whole suite of tooling that we pushed out to our endpoints. And its goal was to really focus on two things: real-world patterns of persistence and real-world patterns of compromise. And so how do you start to detect those sort of things when attackers are operating on your endpoints? And we really took a lot of lessons learned from detecting hostile persistence mechanisms. So let me share some stuff with you on that. So if you're looking to detect hostile persistence mechanisms, and again, you're focusing on a lot of the basics, although this actually catches a fair amount of the customized tooling as well. The first thing that you do is you go look and see, okay, how does an OS actually persist programs across reboot anyway, right? And you go identify those sources, and you say, okay, that's what I'm interested in instrumenting. From there, you treat additions to or modifications of those events of those resources as an event. So, in Windows, this would be like your registry and an auto-exec bat and that sort of stuff. In Linux, it's like your initd and RC systems. Anything where at boot time it actually executes a program, that's what I'm talking about when I mean OS mechanisms here. So for rare events, it's really nice. It's kind of like your non-technical users. You can just alert on every occurrence because you will have false positives, but the false positive cost is so low, right? Even if you have false positives, but you have one every week, that is incredibly low and you can deal with the cost of that. If cost of investigation is 30 seconds. So when you have certain events occurring on endpoints, like new SSH keys showing up on them, cron tabs being created, things like that, things that happen very infrequently, you can just alert directly on those events. Because what's really nice about those, like from actually having done it and in practice, is you can look at them and instantly determine if it's interesting or not. Right? You can look and see, oh, new SSH key was created for that username who's a new engineer today. Cool, that makes total sense. New cron tab created, same thing. New cron tab created on a customer service rep laptop, that's interesting. I want to go learn more about that. For events that happen often, you need to aggregate across, this is why you need to push instrumentation to the entire organization, because you need to aggregate across the entire organization. So let me give you a specific example, which is kernel modules. So one day we sat down and we were like, okay, we would love to know if a malicious kernel module was loaded somewhere in the enterprise. Like we would want to know if on an endpoint, something malicious loaded on there. How do we go about doing this? So let me share a spectacular failure with you, which is we thought that this would be, after boot time, we thought kernel modules wouldn't really get entered into the system at all. We thought basically they all get loaded at boot time, and then anything that shows up is probably interesting and anomalous, like cron tabs and things like that. Totally wrong. Completely and totally wrong. If you go look in OS X, kernel modules are entering and exiting the kernel consistently. It's crazy. You can't just whitelist and blacklist the names, right? Because you can't say, okay, don't show me any kernel module that's com.apple.whatever, because the first thing your attacker is going to do is name it com.apple.totallylegit.biz.ru. So what you really want to know is this kernel module organizationally unique? And the way you kind of break that out as a question is, did module X that just got loaded on endpoint Y get loaded on less than N systems across the organization in the last few days? Right? So did this just show up and it's the only system that it showed up on? That's anomalous. It's not that it came into the system or left the system or anything like that. It's the only laptop that loaded that kernel module. That's interesting. And we actually had really good success with one of our earliest successes with TripYarn was exactly this actually. And it was totally like a high point in my career at the security team there, which was someone on one of our teams they got hit by a pop-up that said, hey, totally standard malware sort of install. It's a pop-up that showed up and said, hey, your Mac is unprotected. You don't have your firewall enabled. Click here to download and enable the firewall, right? And so they did the wrong thing for all of the right reasons. They're like, hey, I care about security. I don't want to not have a firewall. Let me click here and install that. And this lit up a whole bunch of different things inside TripYarn. But one of the biggest ones was the kernel module that suddenly popped up and said, like, Mac Defender Firewall.kext or something. Like something that's so anomalous and so clearly not legit that we actually went over to their system, physically just walked over in the office, and they were still clicking next during the installation process in the middle of it. It was awesome. It was completely awesome. Right? They were still like clicking that, and we walked over like, whoa, yep, okay, thank you. Abort, like nuke that system. But it was really cool. It was really cool to see this work. In just the same way that it was really cool to learn that you can't just alert on every kernel module that comes in. That's totally not effective. So actually, I kind of want to divert that into a way of thinking about, as you're either building or deploying defensive tooling like this, a way to think about it from the offensive mindset. So you want to think about this. One of the greatest things to do as an attacker, once you land on a system, so post-exploitation, you land on a laptop of some company. What you want to do is make as absolutely minimal amount of your code touch disk as possible. Right? When you want something to land in there, you ideally don't even want to touch disk at all, because then the forensics people can go have fun. And especially what you want to do, if you do have to persist a disk, what you do is you land on disk and you essentially just do kind of a CNC mechanism on there. So all it does is, this is some little rootkit that I wrote that lands on someone's laptop. When their laptop starts up, all it does is pull some IP address and says, hey, do you have anything for me? And every now and then that IP address will say, yep, here, I want you to do X. And it'll be like, okay, great, I do X, and then I ship back the result. And the reason for that is kind of the counterexample to Stuxnet. So Stuxnet, they had an interesting challenge because they were going against air-gapped targets. And so when you have air-gapped targets, you can't do reliable CNC for them. Or you can, but it's very high latency, right? You have to wait for somebody to walk something out of the facility, and then it communicates back out to you. But as an attacker, that kind of sucks. And so what they had to do was they had to build a lot of their actual goals into their tooling. So inside the Stuxnet payload, it had everything that it was supposed to do already inside there. So they had some function probably named like make centrifuges spin really fast. And the problem is for them as defenders, when we go discover that some system is compromised, and then we find that rootkit on there, and then we start to reverse engineer it and see what they did, if we go look and see, okay, there's a function called make centrifuges spin really fast, now we know what our attackers were after. Right? If there's another function called take webcam photo, okay, they took webcam photos from every system that this was on. Right? You can learn what your attackers' objectives were just from their tooling. Flipping that back around, I realize I'm hopping back and forth a bit here, you don't want that to happen to you. Because your attackers, this is really interesting, your attackers will do IR and kind of discovery on your defensive systems. When they land on your systems, on your endpoints, they're going to take a look at what is all the defensive tooling that's on here. You kind of assume as an attacker that you probably got busted the first time anyway. So let's just be loud and noisy that first time. Let's see what AV they're running. Let's see what kind of HIDS products they're running. Let's see what sort of security tooling is in that environment. Oh, even if they're doing something custom, great, let's grab a copy of that. Let's go reverse that. And now when we come back, let's make sure we don't trigger anything on any one of those systems. Now, as a defender, what you want to do is you want to specifically collect as much data from the endpoint as you can, but make your decisioning on the back end. Make your logic on the back end. So your attackers, they can learn, okay, this defender is collecting all of this sort of data, but I don't know what their thresholds are on that. I don't know what they're actually alerting on out of that. I don't really know how to avoid that. I know that if I do anything that lands inside of that kind of collection window of theirs, I might be hosed or I might not be hosed. And that's uncertainty that you can actually use as a weapon against your attackers. It also has really practical effects in that as you want to change what you're alerting on and as you want to change like what your thresholds are for anomalies and things like that, you can do it in one central point. You can do it back on the back end. You don't have to change the software that's out there deployed everywhere and redeploy it to your entire organization just to change some sort of setting like that. Okay, organizational level persistence. So that was persisting on one person's laptop. I compromised an organization. I want to persist to the organization. And this is interesting. We've seen a lot of this over the past couple of years, and I think that we'll see more of it. Because when you think about the actual objectives that attackers are going for, it's not to have a rootkit on your laptop. No one cares about your laptop. What they care about is the data. And so this is kind of the shift to cloud and things like that. I want access to someone's data. If I want to read the CEO's email of some organization that I compromised, I don't care about having a rootkit on their laptop because quite honestly, they're going to lose their laptop, they're going to throw it away, they're going to get upgraded all the time. It's costly for me as an attacker to maintain persistence on there. It's much less costly to read their email in other ways. So you want to kind of do this as, I'll give a specific example of that in a second, but you want to kind of do a mixed approach of automated anomaly detection around this and then manual reviews. So things like for VPNs, for example, generating a new roll-up of all the new VPN keys that were created in your organization that day and CCing the IT team and the security team on that. Just say, hey, you guys, hey IT team, you don't have to respond to these emails at all. Just take a look at them and see, here's all the keys that you supposedly created today, and if you suddenly see keys on there that you did not create that day, go hit the big red button and page us. That's it. So you can do that for everything that happens during the normal day, but then you can also do automatic alerting on things even as simple as kind of off business hours and location stuff. If one of your IT help desk people created a new set of VPN keys at 3 in the morning from, make up a city, that's probably anomalous and that's probably interesting. That's the sort of stuff that you can actually start to do automatic alerting off of. Okay, so let me give a specific kind of case study example of Gmail. So for where you want to go read the CEO's email and you want to maintain persistence that way. We wanted to know, this is kind of similar to a compromise of like a Windows domain admin, for example. We wanted to know if anyone compromises any of our Google Apps infrastructure. So there's actually 2 not very well-known APIs called the Admin Audit API and the Email Audit API inside Google Apps. And they're buried in this crazy Google UI. You go to like reports and all this. Come find me later if you want to look at them. They're not well documented at all. Anyway, they actually exist though. So what you can do is you can pull down logs via those APIs about your organizational usage. And from there, you can store it so you have actual IR records. So if something happened a year ago and Google won't give you those records, you have them. And then you can start to do interesting alerting on this. So whether that's things as simple as sign-ins from unusual locations or times or things like that, those are the sort of things that are going to be the more false positive prone stuff. So you'll have to kind of figure out what, and as your business scales, that is something that gets more challenging there. If you're a 100,000 person organization, sign-ins from unusual times, you have offices everywhere in the world. Like that doesn't really work so well. If you're a 500 person organization with 2 offices, that works really well. The things that even as you get to huge organizational size that still work really well is creation of new kind of top level admin accounts. So even if you're a 100,000 person organization, the creation of new like domain control or domain admin level accounts is fairly rare. It's rare enough and serious enough that you want an alert to go off whenever it happens anyway. And then any changes of system-wide security settings, so 2-factor auth settings, things like that, disabling required SSL, that sort of stuff, those sort of policy changes that should just never happen, alert on those. Mail forwarding filters is an interesting one. So I kind of skirted around this a second ago, but this is how you maintain persistence at the organizational level if you want to read your target's email. There's 2 good ways you do it. One is if you've owned up a specific, like some admins inside the organization, you go create a mail filter for the CEO of that organization. And all it is a blank mail filter that says, forward all incoming email also to this address. You don't interfere with the delivery of their email at all, but everything that comes in, you also forward out to totallylegit.hushmail.com. And then you read their email that way. And that's how you maintain persistence to the organization, because it doesn't matter if the CEO changes their laptop or anything like that. The other way you do that is with MX records for the entire organization, and you direct the entire organization's email through your mail servers. Yeah, it's awesome as an attacker. It really sucks as a defender. That's another interesting sort of alert, right? How do you know when your MX records change for your organization? That's the sort of stuff that's really interesting to go instrument. So this is just like a screenshot of an example of, okay, this day, this actor coming from this source added a group member to this group email and all this. Now, it's hard to tell with these things blanked out, but the nice thing about this sort of stuff is that it is near instantaneous to look at this alert and be like, this is totally fine, or this is totally anomalous, right? A new employee getting added to the customer service rep group email, cool. The random customer service rep getting added to the senior executives mailing list, interesting. That's the sort of stuff where you want to make it so that when your alerts come out, ideally you have all of the context you need to make a decision in that alert right there. You don't have to go look at additional systems. Okay, lateral movement. Shout out to any Street Fighter II fans in the house. Okay, we're going to focus on lateral movement could be a week-long talk in and of itself, so I'm just going to focus on 2 kind of small things. And that's when an attacker lands inside your environment and is trying to do kind of discovery of your environment, at the network and system level, and then at the informational level. So this was it. I think this and like the next 3 slides or so are the dumbest ones in this deck, and they're if you showed me these without having actually done them, I would laugh hysterically at them, except they actually work. That was the really funny part to me. So we deployed a bunch of endpoint firewalls across the organization, and we didn't use them as defensive mechanisms. We used them as alerting mechanisms. When you start to rethink deployment of firewalls not as a blocking mechanism, but as an allow and alert mechanism, it starts to become a really interesting tool. So how you start to couple this is building alerts around services you don't use in your organization. So if your laptop, think again from the attacker side. Attackers all have their favorite sort of bags of tricks and their favorite sort of techniques, right? Some of those could be, to pick a completely arbitrary example, Microsoft SQL. If I land inside an environment, I want to see what SQL servers are out there, because there's going to be one that still has XP command shell and SA with a blank password. Like, it's just going to happen. Been there. So if you don't use MS SQL in your organization, and something starts trying to look for MS SQL, that's anomalous as hell. That's really interesting. And so one of the ways that you can detect this is from the endpoints themselves. Obviously, you duplicate this effort at the network layer too, but to give an example out of OS X, you can actually push down PF rules, like OpenBSD PF, to OS X boxes and enable them on there. And what you do is you say, okay, allow outbound any traffic from this laptop, but if it's talking to these ports, send an alert. Send an alert back up to a central service. So your attacker lands on a laptop and starts looking for services that they're interested in, and they don't get blocked at all. All of their traffic's still going. Meanwhile, alerts are lighting up all over the place. Because they're not, if you block to an attacker, that signals there's something there that they need to route around. Right? If they can't get to a port, okay, now that's some network ACL that I've got to go pop another box to get around that ACL and go there. But if I can just get there, meanwhile alerts are going off the whole way, you're going to win that kind of detection race. Like I said, alerting and don't block. These also counter timing-based evasions and things like that. So it doesn't matter if you're doing Nmap on the slowest setting or anything like that, and you're only sending one packet a week, right, out from an endpoint, you're going to have to send some traffic out to those services. And if you're alerting on that from your endpoints, it doesn't matter what any sort of evasions you're trying to do on that. At the end of the day, you have to talk to that port. And so if you alert on that, you're going to get that detection. Information discovery. So what systems, internal systems, provide the most information that's very helpful to attackers achieve their goals? This is really easy. It's what everybody uses to achieve their business goals, right? It's your wikis, it's your source control, it's your bug tracking. That sort of stuff is some of the most interesting data to your attackers out there. I can think of multiple occurrences where a lot of the high-profile breaches that we've read about, a lot of the attacker goals were to go in, scrape every security bug out of their internal bug ticket, out of their internal bug tracking system, and then leave. Because there you go, you got all the persistence mechanisms you ever need out of that. Your source control as well, right? That's grabbing a copy of source and then go finding your own bugs out of that. Wikis, like it's lovely if you can go find an updated network diagram in a wiki, which is, a unicorn, but if that actually existed, it's fantastic as an attacker, right? Because you can go, okay, this is the environment I'm inside. I don't need to do any of that discovery stuff. I just downloaded an image of the network map, and I can go see what's actually going on. And now I can just go talk directly to that system. I don't have to do any discovery at all. So what you want to do as a defender here is instrument these systems the same way you would other high-value infrastructure like production servers and things like that. What you want to look for are the sort of organizational anomalies that kind of go back to other systems there too. Usage outside of normal hours. Quite honestly, your attackers are very rarely in the same time zone in which you operate, right? So you can start to look for both anomalous activity outside of hours like that. You can also look for bursts of activity, and this is really the effective one. Bursts of activity inside your internal documentation or bug tracking, right? Even your security team never views all of the security tickets, ever, right? They look at one or two that they're working on that day or that week. And if they view all of them at 2 in the morning, that's definitely malicious. Cool. Second section here. Increasing attacker cost. And I get to use a picture of Big Bird making it rain, which that's really the high point of any speaker career right there. Okay, so a bunch of just little things like this. We're getting near the end here. So the first one is we were sitting around talking one day around, does everyone remember the DigiNotar attack, which was a CA that got compromised? The attackers compromised that CA. They used it to issue valid certificates for Gmail and Facebook and high-profile services, and then they went and man-in-the-middle a ton of people's traffic. We were trying to think, like, how could we reduce the likelihood of that happening to our organization? And specifically what we want to focus on is not that you can't really solve that problem without completely opting out of SSL or PKI entirely. But what would really suck is if some CA that we never used in our organization got compromised and used to attack us. Right? It's not that like, oh, if Komodo gets owned, okay, well, like everyone's screwed. Or VeriSign gets owned. But if random AAA, what is it, like trustaaa.net or something, there are so many. If you go look at your CAs that are in there, it's like, one is like A1 plus security certificate services. Like these sort of the shadiest things that you would never believe are actually real are totally in all of our OS CA stores, which is kind of scary. So if one of those got owned up, how do we make it so that they can't then man in the middle of our organization? So what we did is we did a bunch of network traffic analysis from our corporate headquarters to seeing what CAs were actually used by our organization. So what we did is we recorded whenever web traffic went out and there was an SSL handshake, record the certificate and see what the CA was that signed that certificate. And then throw away everything else about it and just increment a counter that says, I saw this SSL CA. All right, I saw this one, I saw this one, I saw that one. and run this for several months and see from the data, what are the CAs that are actually used by your organization. What we found is less than 29% of the CAs that were deployed across our organization were ever actually used in a 6-month period, which was crazy. So what we wanted to do, here's kind of the raw results. We published a bunch of them up there, but you just watch it drop off incredibly quickly. What you want to do is you want to remove only the unused ones. So this is what we started to do for some pilot systems, is disable the ones that are completely unused. Now, you're right to immediately jump to like, okay, well, are you teaching users to then click through SSL warnings? That would be even worse than this whole project, right? You do not want to do that. That's why this isn't a one-time decision. You don't just disable CAs and then walk away and say, I'm done here. What you do is you continuously monitor, and when a new CA shows up in that list of being used, you re-enable it on your systems. Because you absolutely do not want to teach users to click through SSL errors, but if you disable the unused ones, and one of those gets owned, they can't then be used to man in the middle of your organization. Okay, Java. Java is cheap, reliable, and efficient. It's awesome, except that's only for attackers. It's not for any of us. So we get to get rid of it. So we pulled Java out of Java web plugins, not Java the programming technology. Java browser plugins we nuked from the entire organization. What did we learn from doing that? Almost no groups actually need it. I mean, you can tell you right off the bat who are the almost guaranteed people inside your organization that need it. Your finance team and maybe some of your network operations team, depending on what vendor equipment you have. What we did for them is we built dedicated Java jump boxes, right? So you could essentially VNC to a box, and from there, from that box, then go use whatever needed Java, and then disconnect, and you were done. And the great thing about that was there were a bunch. There's no Java on any laptops. So someone sends in a link or a watering hole attack or anything like that, there's no Java to exploit on any endpoints. The boxes with Java on them can't hit the internet, or if they can, it's only the specific sites that need to allow Java. You can just re-image those boxes all the time. And then there's only a few boxes to patch when you need to patch. The nice thing here is if you've done the first 3, then you don't care if it takes a month to patch because those boxes can't really hit anything. The interesting thing in OS X, this was a wonderful lesson learned, is that when you apply security patches, Apple very kindly re-enabled Java for you in the browser. You have to just nuke it with fire continuously. We thought we were feeling really awesome because we nuked Java from the entire organization, and then all of a sudden it just started showing up, and it started showing back up with like our most technical users first, and we were completely confused because like those are people who would never install Java. Like, why is this showing up? It's because they were the first people to apply security patches. The most security conscious people actually were the first ones to reintroduce Java into the enterprise. So you have to just nuke it continuously. I think by the end we ended up cronning something on a like 10-minute or 1-hour window to just nuke Java all the time. And then you watch it. It's really funny. When you start to graph it, you can see like, oh, a security patch came out because look, we're watching Java showing back up and dropping back off again. Okay, browser updates. So if we can start to remove the plugins that people use to own up enterprises, now they move to browsers themselves or to other targets like Adobe Reader and that sort of stuff. How could we force browser updates in a culturally sensitive way? There's no quicker way to get everyone to stop talking to you as a security team than to force reboots. Everyone hates you, no one wants to grab a beer with you afterwards, and we like happy hours. So you don't want to do that. We wanted to enforce a way in which they'd be up to date without being a complete pain. So what we did is we built browser detection logic into our internal SSO point. And we tried a few different things. I'd recommend this approach for your organization. So what we did is build it into some sort of internal point that the vast majority of your enterprise hits on a daily basis. So usually that's an SSO point, maybe it's an intranet site. Whatever it is that people hit almost every day inside your company, that's where you build this. User experience is totally the key here. You need to communicate how quick and painless it is to update. So what we did there is, if you had an out-of-date browser, in this case shown by Mosaic, and we need you to upgrade to the newest Netscape Navigator 1.0, what would happen is you hit the SSO point, and it said, your browser's old, you need to update it. What this doesn't show on this screenshot, because obviously I doctored it a bit, is you say, okay, this is your browser. You need to be here. What you do is you click here, and then you click here, and you're done. Put 2 red arrows on there and say, click this, you're good. The other key is to show provide a like emergency override button. That's kind of the key, because you're always going to have somebody who's in a meeting with like the CEO or something, and they tried to pull up their prezo, and the security team just blocked them, and they're incredibly upset about that. If you provide a mechanism where you can say, okay, I'm in a meeting, I need to get through and do this meeting, and then I'll update later, I promise. If you provide that and you message it as like, this is like a fire alarm, it's there if you need it, but it's going to set off alarms when you pull it, people actually respond to that. It's really interesting. And then put in a sad kitten because you say your old browser is making this kitten very sad. Bam, you got it. So here's what we couldn't believe, right? This sounds fantastic in theory. Again, if somebody stood on stage and told me about that, I would be kind of amused and kind of rolling my eyes because there's no way that would actually work. What we couldn't believe is it actually did. So just updating, this is out-of-date browsers in the organization. And you see it be pretty flat, new version comes out, everybody's out of date, and then the part that we couldn't believe is this drop, right? You expect it to plateau and everyone's just out of date. It totally worked. If you just ask people and you show them how easy it is to update, they do it. And then you see these little dips as people like come back from vacation and that sort of stuff. I actually told this story earlier. People will install malware because an ad pop-up told them to. Shout outs to Bonsai Buddy and some old school stuff. What's interesting, the other lesson learned that we had out of that, in addition to detecting kernel modules and that sort of stuff, is that you can almost entirely kill this entire attack vector for free by pushing ad blockers to your organization. It's awesome. Push this out. We'll get to that in a second. Push this out, and you make pop-ups go away. And now people can't do they can't do kind of drive-bys, like just malware drive-bys, where it says, hey, you're like this is legit, click on me to install. They also can't do, in a lot of cases, kind of watering hole style attacks where they slip a malicious ad into some large advertising network that loads on a totally legit page, and then you get attacked that way. But if you're just killing advertising, apologies to any ad-supported business in the room, but this works really, really well. Okay, security awareness training and pool sharks. So historically, we've focused on reducing the number of people who fall for phishing. This is a fine goal, but it's not the real goal that we should actually be focused on. Or to make it more bombastic, this is the wrong goal. It is a goal, but not the goal. And the reason I like to think about that is if you go from 36% on fire to 27% on fire, you're still on fire. That still sucks. What you want to focus on is increasing the odds that someone will report it. Right? We always tried to trend down this graph of people who fell for phishing. So what we would all do as organizations is you run a sample phishing campaign against your users, and then you name and shame the people who fell for it, and then you rerun it 2 months later, and you hope the graph goes down, and you keep doing that, and you keep running training and everything, and you hope that goes down. The problem is that has kind of a false assumption, because what you're assuming is that one day that graph will get to 0, and it never will. Right? The only way you win in that kind of metric is if it goes to 0 and no one ever falls for phishing, someone will always fall for phishing. What you want as a metric and what you want to increase are the number of people who report phishing attempts in the organization. So you send out your same phishing campaign, and then you keep track of how many people reported it. And you want to reward those people and not name and shame the other people. So what we found super effective was we ran one of these campaigns, and then afterwards we followed it up and we said, okay, yeah, this was a security team, demonstrating a phishing attack. This wasn't real. Everybody's all right. And everyone who reported it to us just got a Etsy gift card, right? So you just got $50 or something for reporting it. It was awesome because we had things that we never even thought about come in then. We had one person who said, this blew my mind. They said that they got that email and they're like, oh yeah, that's clearly phishing. And they stood up to all of their kind of desk mates and they're like, hey, don't click on that, that's phishing. And then they sat back down and went back to work. And they never notified anybody else. That was fascinating to us. If we can get that person to come tell the security team, we can win, right? And especially as people don't run actual spear phishing campaigns against, there's a reason it's called spear phishing. You don't run it against an entire organization, right? So you need to increase the odds that someone's going to report it because the target groups are going to be much smaller, right? If you're running a real spear phishing campaign, you're running it against groups of 1 to 5 to 10. And what you want to increase are the odds that someone in that group is going to report it to security. Because even if 36% still fall for phishing, if one person in that group reports it, you've won. You can start your IR process, you can figure out what they're up to, and you can hopefully shut it down before they achieve their objective. Okay, final large section. Attack simulations. Keeping it classy. Okay, problems with pen testing. Are any people in here pen testers? Yeah? Sweet. Okay. So my background is totally in pen testing too. I'm not going to beat up pen testing. The problem is that challenges with pen testing are well understood in the offensive side, and I'd say that they're less well understood on the defensive side. And typically what you get with pen tests are a kind of vulnerability enumeration. You get a list of things to patch, and then you're like, great, now I'm going to go patch these, patch the most severe in this time window, the less severe in this time window, and that, and that, and that. What they don't give you, and this is the critical piece, is that they don't tell you how a real attacker would actually operate in your environment. This gives you a list of things to patch. What you want to do in addition to pen testing, so vulnerability, I'll call that vulnerability enumeration, you want to do that has value. But it doesn't have, that's not a pen test, that's a vulnerability enumeration. So what you actually want out of that is to see how attackers achieve goals against your organization. And you're not just trying to show, hey, compromise is possible. It is, full stop, right? Compromise is possible. What you want to do is think of this as the feedback loop to your entire kind of security program. Think of it from the AppSec side as like a bug bounty program and things like that. How do people actually attack you and actually achieve goals? From the organizational side, this complements all of those sort of things. It doesn't replace it. The problem is that these sort of things are almost checklists. Like they give you checklist sort of items, but it's attackers who are owning you, not checklists. So what did we learn out of, I tried to distill this down into what did we learn out of this and how would I design kind of an attack simulation program for an organization out of the lessons learned there. The first is to make it goal-oriented. You want to set goals with your attack teams and say, my goals for you are for you to obtain domain admin, obtain source code, read the CEO's email, that sort of stuff. The interesting lesson learned out of that is don't just go to your attack team with a list, actually have a dialogue with them on that and say, if you were attacking an organization like mine, what would you go after? Because this was really surprising to us. A couple of our attack teams came back and said, oh, if I was targeting you guys, I would go for this and this. I'm like, oh, we didn't even think of that. That would have been really bad for us if you had done that. Cool, we'll add those into the goals. The next is scope. Attackers and offensive professionals love to make fun of defenders around scope. There is nothing more hilarious to an attacker than the concept of scope because it does not apply to them, it only applies to your defenders. How do you actually manage this as a security organization? Because it's a challenge, right? And a lot of times you have to worry about what happens if a real attacker took out my production database on accident, like that's an actual attack, we're gonna respond to that. But if some team that I hired took out the production database, I'm in a ton of trouble, this is gonna be a whole battle internally, like there's real concerns around that. What we learned as an effective method for that is have your attack teams have a contact with you guys and call before they're gonna operate in some sort of semi-dangerous way, right? If they have, I'll give you an example of this. One attack team got to a point where they were going to go target a production database, and they had a MySQL ODay for that, and they're like, oh, honestly, that exploit lands maybe 80% of the time or 90% of the time, but Murphy's Law on this, it would be the 10 or 20% of the time that it didn't work here. What do you want us to do? And so we sat back and we thought about it, like, okay, here's what we're going to do. We're going to create an account for you on that production database and just give you SSH creds. And we're going to treat it as if you had thrown that exploit against it and landed on that box and just continue operating. And that way we mitigated the risk of that production system going down, but they were able to continue the testing as if they had gone towards that goal. You want to simulate the realistic compromise patterns. So this means starting an attack team on your endpoints. Here's a standard build of a laptop. Go. Start from there. If you're worried about kind of SQL injection or remote code, so SQL injection, start them on a simulated production database. You're worried about remote code execution in like WordPress or your web apps or something like that. Start them on a production web system. Have them start where a real attacker would start. And don't just give them VPN access to your internal network, because that's not how, your attackers will get to that point, but that's not how they actually start. They land on some system. Encourage them to use ODays throughout the engagement. ODays are real. And then break the simulations down into iterations. This is kind of a much more logistical thing, but something we found super effective, which is that your typical pen test engagement is what's called like a 2x2. Right? It's 2 people, 2 weeks. And they start operating, you get a status report that first Friday, and then you get a deliverable the following Friday. The problem is, for so much of compromise, it actually happens way quicker than that. You want to compromise a modern organization, you're going to achieve a ton of those goals in the first 48, 72 hours, depending on how your style of operation is. So you want to simulate that in here. Given that your goal is to get data on how people actually operate in your environment, break it down and say, okay, first time you achieve one of those goals, great. Start from the beginning and rerun it again and do it in a different way. And rerun it again and rerun it again. And give me a big set of data as to how you achieve those goals so that I can use that to influence how I build defenses. Right? What you want, the output from these should not be stacks of vulnerabilities. It should be an attack chain saying that we went from A to B to C to D, and what steps they took on that and why they took those steps. That's really interesting and critical, is that for your attackers, why did you go from A to B? What was interesting about that? And just as importantly, what they didn't do, right? We had this happen where we had built a bunch of really interesting instrumentation and detection in this one area of the network. And we ran an attack simulation, and the attackers never showed up there. Like, we just spent like 3 weeks building this awesome detection that like we were totally going to catch these guys, and then they never showed up there. And so what can happen out of that is like, why didn't you go that way? We totally expected you to go that way. And like, oh, well, back at step B, we found a network diagram, actually. And so we didn't have to go do all this network enumeration. We already knew where we wanted to go. So we just completely bypassed that one area and just went directly to a target system because we already knew what the network looked like. So learning why they didn't take steps is just as important. You want to simulate what are the behaviors and patterns. So you want to vary profiles too. Attackers don't operate all uniformly. What you want to simulate are like people who do kind of the smash and grab style attacks versus quietly maintaining persistence, this sort of stuff. Right? Your attackers are not just all going to operate in one way. They might be only interested in your user database. They don't care if they get caught. They're just going to break in, grab that, and go. And even if you detect them, they probably exfiltrated enough data that they've won. Right? That's one attack style. Another attack style are they don't even want to achieve an objective at first. Their objective is just to maintain a foothold in your network for later on when they want to actually achieve objectives. These are all varying attack profiles, and they all operate completely differently. You want to run as many of these different profiles as you can, because as a defender, what you want to see is what overlaps between those two. That's where you get the most value from building your defenses right up front. Right? If I can build some detection mechanism that is reliably going to catch people who are just trying to quietly maintain persistence, and for people who are trying to actually just get the user database and run, that's where I'm going to get the most bang for my buck on building on that. So that's pretty much it. The thesis of this talk is think about defense through an offensive lens because that's how we're getting attacked. Increase attacker cost wherever you can by removing like cheap compromise vectors, right? Getting rid of Java, getting rid of the things that make it very easy and cheap to compromise a network. Build your detection mechanisms around real attack patterns, and then don't be afraid of having internal kind of product development and tooling capability inside your team. You're going to need to build custom stuff, and don't be afraid of doing that. And you guys are awesome. Thank you. I think I have time for questions. I have no idea. Let's do them, though. Yeah?
I have a question of what you said about firewalls. Mm-hmm. Where not blocked.
Yeah.
So, say an attacker is attacking from another country, you're not in the office.
Mm-hmm. Great question. And the question was, so I mentioned like don't use your firewalls to block and use it to log instead. It's actually additive to that. You have your firewalls that block and things like that, but then you can also use firewalls as a detection mechanism, right? So you have your ones that block, but then you can have a completely another set that all they do is look for patterns of access that don't normally happen in your environment, right? Somebody scanning your network for Microsoft SQL, when you don't use Microsoft SQL, you can use a firewall, you can use an IDS, whatever you want. That's kind of semantics there. Looking for that sort of network traffic and alerting on that, but not blocking it, because that doesn't give away to the attacker that they're kind of busted there. Does that make sense?
Yeah.
Okay.
What are your thoughts about using lures and honeypots internally to try to track?
Question was around thinking about using like lures and honeypots internally to kind of as a detection mechanism. In theory, they're fantastic. In practice, attackers usually don't go for that sort of stuff, honestly. Like attackers are going to use your network in the way that you use your network. And you don't use honeypots, right? To get your job done, like your developers aren't going to some honeypot system in the middle of the day. So if they land on some developer's laptop and they're seeing what that developer is connecting to, that's the systems they're going to try to move on to.
With the alerting that you mentioned, it's kind of, you're achieving the goal of a honeypot throughout your entire organization.
Exactly.
Because you set all your firewalls, internally to alert based on interesting heuristics. Your honeypot is the organization. Somebody is in there doing something, right?
Exactly. I'll give you one that I don't put in these slides because these are published. Instrumenting your systems, take the concept of a honeypot and build it onto your actual systems. So take your internal source control and wikis and things like that and alert on if anyone ever searches for password. That's how you do honeypots in real organizations. Because you're use them on there. If someone searches for password in your wiki, like that's an attacker.
Is TripYarn something that's available?
There's a version of it that's called Midas. It's up on GitHub, MIDAS. It is a framework, not a just product that you plug in and deploy. It gives you all of the framework pieces that you need to do that inside your organization, but you need to go write the modules and stuff.
So that's something you could, in theory, adapt to either Windows or OS 10 into your endpoints?
Yeah, the thing that's up there is for OS 10. Because none of our organizations run Windows, so there's no, I know, right? You're not allowed to work in like Brooklyn cafes if you have a Lenovo, so you had to. Yeah, I did not plant that question for the record. No, we're taking a lot of the web application defense lessons learned. It's this, but for the web application or for the application side, application defense. So a lot of the things that we learned running security at Etsy of how do you actually impose attacker cost and have the kind of instrumentation and detection around vulnerability discovery and exploitation, we're doing that on the web side. So if you have like a mobile API, if you have any sort of web services or web apps or anything like that. Yeah. No, this is a product that we're developing. Yeah, should be fun. More questions, please. Yeah.
How the process to remove Java continuously for the endpoints was implemented? Because it seems like a never-ending task.
Yeah, it's a 2-line shell script that we pushed out to all of the OS X boxes. And you can just, thankfully, on OS X, your browser plugins live in 2 spots. One in a OS area, and then the other is Firefox in its own area. And so you just RM those every 10 minutes.
And what do you do with the embedded Java? So there are some applications that have Java embedded on it.
Yeah.
How do you do that?
Yeah, so dealing with, you mean ones that you have to use that have Java in them?
Yeah.
Yeah.
Embedding the code. Inside the code.
So it's only, I'm not certain I understand, but the,
Well, we have some applications that have Java embedded.
okay.
That doesn't come easily when you do reporting or asset discovery.
Yeah, if it's not a Java applet, if it's just Java, the programming technology, then that's fine. But Java applets, so the way that we did it is if you have to use a Java applet, you have to go to a jump box that can only hit those sort of systems. The nice thing is after we built that approach, there's, what's the name of it? There's a thing that you can deploy for your browsers where you can whitelist what can even instantiate Java. Actually, no, Java does that in the latest, in like Java 8 or whatever. You can whitelist the host that can even talk Java to you. And so if your organization is able to use the latest Java, you can just do that and say, okay, these intranet sites and these internet sites can talk Java, but nothing else can. And if you can't remove Java entirely, at least you can whitelist the things that can only talk to it. Does that help? Okay. Yeah.
When you said that an attacker can get emails forwarded to them,
Mm-hmm.
that's like a trick. Can't you trace where those emails are going and find an attacker?
Yeah, no, good question. Usually, you forward that to some webmail in some country that you don't have that whatever. If I attack company X, right? I'll make up countries here, but right, like if company X is in the U.S. and I'm an attacker, I'm going to forward them to some webmail provider in Russia, right? Because the jurisdictional issues are going to be enough where they're not going to share anything, and then I access that webmail through Tor through some popped boxes or something. That's how you do it as an attacker. More questions, please. Cool. Well, thank you guys for coming. Yeah, I'll be around for a little bit if you want to come ask anything afterwards. I'm more than happy. So thank you.